Welcome to another segment of High School Geometry with Netz and Weichel. This is Mrs. Netz.
And this is Mrs. Weichel.
And today we are looking at 7.5 radians. What will we be learning? Well, by the end of this lesson, I will be able to convert angle measurements between degrees and radians. Why will we be learning this? Well, degrees are the preferred way to measure angles in upper mathematics, so we can lay the groundwork for this new measurement unit. How will you know it? Well, you'll know you've mastered it when you have equal radian and degree measurements for a single angle.
Wonderful. Let's go ahead and get started. So first, what are we used to measuring angles in? We're used to measuring them in degrees. Degrees, we have 360 degrees for one full revolution around a circle. So you can see here in this little video that as you go around the circle, and we stop a few times, we hit our main degrees, and then it goes all the way around to 360 degrees. 360 degrees is believed to have come from the fact that long time ago, our year was based on 360 days. I think that's interesting.
1 degree for every day.
There we go. One full revolution around the sun. So that is what we are used to. 1 degree is 1/360th of a circle. Yeah. So
makes total sense.
There you go. Our new measurement of unit is going to be a radian unit. It's made by taking the length of a radius and wrapping it around the circle. 1 radian, which we can abbreviate to rad, R-A-D, will have a degree that is equal to about 57.2958 ... So I, again, have a little video to kind of illustrate what this is going to look like. So when I say we're wrapping a radius around the circle, you take the radius and you literally wrap it around. And then like the slice of pizza that forms, that's going to be the radian measurement. So I'm going to play it one more time so you can see the radius goes around the outside of the circle, and then we connect the ends, and that forms 1 radian. And because all circles are similar, that ratio of radius to the full circle is always going to end up to be the same, like percent of the circle making that radian measurement. So conversion. So not conversion. We are going to first talk about how many radians make a circle. So we know 1 full circle is 360 degrees. Well, how many radians would that be?
Another thing you might want to think about here is radian sounds a lot like
radius.
Maybe they're connected.
Maybe. So we know that a degree measurement of a radian is about 57 degrees, a little bit over 57 degrees. So if you actually do the math or get out your protractor and figure out what that's going to look like, you end up getting 1 radian is right about there. It's a little over 1/3 of half of a circle, or a little under half of a circle. If you go one more about 57 degrees, you get a 2nd radian measurement right here, which is again just under 2/3 of a circle, because 1/3 of this semicircle would be 60 degrees. So we're kind of just under that. So if we go a 3rd time, we're not quite getting there, because again, 360 degrees would get us to that semicircle. So we have a little bit extra. And again, if you do the math, you end up getting this little extra radian piece right here. Actually works out to be 0.141592654 ... radians. So if we're looking at what makes a semicircle and you add up all the radian measurements that we have, it should be a very familiar number to many, or hopefully all of you. We have 3.141592654 ... radians per semicircle. What is that number representing?
Pi.
Pi.
Hello.
So 1 semicircle, or half a circle, has 1 pi radians. So if a semicircle is 1 pi, then a full circle, or 2 semicircles, would be equal to
2 pi.
2 pi. So 2 pi radians makes a circle. Now we're going to get into the conversions. So I forgot about that last screen. So we're going to go, what year did they learn this? You're my master at math.
I agree, but if you're talking about dimensional analysis, that's a little bit Algebra 1 and then us.
Us, okay. So we are going to convert
Ooh, but guess
yards
what?
to inches. What?
Sorry. Guess what I saw today in an Algebra 2 classroom?
What?
They were using dimensional analysis. Gets even better. Guess what was going on in the chemistry classroom at the same flipping day? They
Same
were
thing.
doing converting moles to like something, I don't know, chemistry's too hard for me, but yeah, dimensional
Cool.
analysis.
Very cool. All right, so this is important. So
Maybe.
you need to be able to convert between units. So what I have here is just a little review as far as the units of measurement. To convert yards into inches, we are going to multiply the yards by the conversion factor. We're not going to jump straight to inches. We're going to go through each unit of measurement. So we should know that there are exactly 3 feet to every 1 yard. And then we know that there is exactly 12 inches to 1 foot. So you can see we just have some fractions that are going to be multiplying here. But what's really cool, if you look at the units, you have yards. If we were to put this over 1, you would have yards on top, yards on bottom, feet on top, feet on bottom. So what ends up happening is those cancel out, and look at the unit of measurement you're left with. It's that inches, which is what we want. Next, you're going to look at, well, what are the numbers you're going to multiply? Again, right here you have 4 yards, which is technically 4 over 1. When you're multiplying fractions, you just multiply straight across. You do not cross multiply. This is not a proportion. So the numbers you're actually going to multiply are the 4, the 3, and the 12. So 4 yards is equal to 144 inches. Yay! Now we're going to do the same exact thing with hours. So we have 2.5 hours that we want to convert into seconds. So again, I'm going to go through this in baby steps. We know that for every 1 hour, there is exactly 60 minutes. We know for every minute, there is exactly 60 seconds. If you look at your units of measurement again, the hours would cancel out, the minutes would cancel out, and you're left with seconds, which is what we want. The numbers you would multiply, we have this 2.5, 60, and 60. So if you multiply all that together, you get 9,000 seconds for 2.5 hours. So there you go.
Easy.
So when we're converting between radians and degrees, we're going to do something very similar to this. We're just going to use the conversion factor for between degrees and radians. So let's go ahead and do that. So we know that for every 1 circle, there are 2 pi radians. So we know for every semicircle or half circle, there is 1 pi. Well, for every 1 degree, we know that there is pi over 180, because if you were, again, to solve this out, 1 pi is equal to 180 degrees. Well, divide the 180 out, you get pi over 180 for 1 degree. So our conversion factor is going to be pi over 180. So we're going to multiply this 100 degrees by pi over 180. Again, you need to understand how to multiply fractions. For this first step, you are not going to need your calculator necessarily. You are simply going to multiply 100 by pi, which gives you 100 pi. The 100 is technically over 1, so you would multiply 1 times 180 and get 180. As you know, you've heard me say it, I'm sure Mrs. Nett says it, you always simplify your answer. So while this is an answer, it is not the simplified answer. This needs to be reduced. That pi sign, think of it like we think of our radicals and a variable. It doesn't move. You're just reducing 100 over 180. So the zeros at the end would cancel out. So really you're just reducing 10 over 18, which would simplify to 5 pi over 9 radians.
If you do not know how to do this with your calculator, simplifying fractions, please, please go to your math teacher so we can show you, and that way you're not getting these problems wrong because you have difficulty with fractions.
You can type 100 over 180 in your calculator and we'll give you 5 over 9. So yes, please talk to us if you need help knowing how to do that on your calculator. So that's all it is. You just are going to convert degrees into radians. That's exactly what you will do. Now, what if we want to go the other way? Well, how do you undo division?
With multiplication.
So, and how do you undo multiplication? You would divide. And how do you divide fractions?
By multiplying by the reciprocal.
So to go backwards, you would multiply by the reciprocal of what we just talked about. It's going to be 180 over pi. And the way that I remember this, I think most students remember the 180 and the pi. We don't typically see the pi sign when we're talking degrees. So you want the pi sign to cancel out. So if a radian measure has a pi sign in the numerator, you want to be able to multiply that by something that will make it go away. So it needs to be in the denominator. So you can see here, you're going to multiply the 7 pi over 12 radians by 180 over pi. And what happens is those pi signs are going to cancel. But then you're going to multiply the numbers that are left. So 7 times 180 is going to give you 1,260. And then on the bottom, the pi sign cancels and you're left with just 1. So 12 times 1 is just 12. So now you just have this that you need to reduce, and it reduces down to 105 degrees.
Not too hard.
Not too hard. So that's all it is. We are going to also go over how to graph an angle on a coordinate plane. So you guys have some fill in the blanks that you're going to need to fill in right now. We will use theta to represent the angle's measurement. The vertex of the angle is always going to be at the origin of the coordinate system if you're graphing in standard form. An angle is going to be drawn. It's going to be measured from the positive x-axis. That's where you always start. And you have to think of these kind of how I introduced what a degree is. It's a revolution around the origin. The starting side of the angle, or the initial side, is always going to be the positive side of the x-axis. And then from there, you're going to basically just rotate the arm of the angle either clockwise or counterclockwise based on what you know already about rotations. And the ending part is going to be called your terminal side.
This should sound a lot like vectors.
Exactly. You don't have these pictures on your notes, but is definitely something I would add to the side. Just as a quick reminder, an angle going counterclockwise, if you remember from our transformation unit, is rotating counterclockwise. So a positive degree is going to be counterclockwise, whereas going clockwise is going to be a negative degree. So we will not give you the direction. We will give you a positive or a negative angle measurement that you're going to be expected to graph. So we're going to go ahead and do this. Because we're not as familiar with radians, as you move on into Algebra 2 and you start working with your unit circle, this is going to get a little bit more familiar seeing angles measured this way. But for now, we're going to convert this into degrees. So we're going to take the 5 pi over 6 and multiply it by our conversion factor, which is, not that, it's going to be 180 over pi. And then just like before, the pi signs are going to cancel. We're going to multiply the 5 times 180 and the 6 times the 1 that's left here, and you end up getting, not that either, oh man, 900 over 6. And 900 over 6 reduces to 150. So we're going to graph 150 degrees. So if you remember what I just said, we start on the positive side of x. It is a positive degree, so I know I'm going counterclockwise. The number that I see here is multiples of 90. 150 is getting pretty close to 180. So we're going to take 180 away, and that means I need to basically go back 30 degrees from that 180, giving you this being 150 degrees. Or you could think of it as 90 plus 60 more, and you get the magic number of 150 degrees.
Now you need to make sure that you always draw your circular arrow, because that tells us whether
Right here.
you're going positive or negative.
That's showing the direction and
And-
which angle you're measuring.
And it shows your initial side and where you terminate, or your terminal side.
Because when you're looking at this, we could have also had a 210 degree angle if you don't show us which one it is. Yes, we don't know which one it is, so make sure you do that. All right, last one. You have negative 8 pi over 3 radians that we are going to graph. So first thing I'm going to do is convert. So we have negative 8 pi over 3 is going to multiply by 180 over pi. That is going to give me, the pi signs cancel. Negative 8 times 180 is 1,440, and then 3 times 1 is 3.
And don't forget to bring over your negative.
Negative times a positive is negative. Next thing you're going to do is reduce this, which becomes negative 480 degrees. So again, this is probably the first time you're seeing an angle that big. So you have to think about a number that's going to help you on here. Well, what's one full circle?
360.
So if I take that out of this, one full revolution is 360 degrees. Well, how much more do I have to go?
Another 120 degrees.
We have to go another 120. So if I go half a circle, I need to go backwards 60 more degrees.
Now, which way are we going, though?
So because this was a negative, we're going to go clockwise. So here is my 360. Then I need to go almost a full semicircle, but we're going to leave 60 degrees left over here. All right, there you are. So right there. So if I don't show the angle, you're not going to know that this was a negative 480 degree angle. So it's really important that you add in the spiral. So this is showing that you are going clockwise. There's 360 plus 90 plus 30 more, which would be negative 480 degrees. And that's it. I'm very impressed by my artistic ability getting that done.
I am too.
Yeah.
I don't think I could do that.
I Googled how to do a spiral arrow.
Right on.
Pretty good. All right, so that's it. That is our trigonometry unit. We are done. You can easily convert between radians and degrees, I hope. If not, you know how to get a hold of us. Again, if you do not know how to reduce fractions on your calculator, please reach out to us as soon as possible.
You know what's kind of interesting is we just finished this whole thing on radians, and that involves circles, and we're going into chapter 8, and chapter 8 is all about
circles.
Oh my gosh, it's amazing.
That's the title of chapter 8, circles.
Oh my God. But hey, Mrs. Michael.
Hey, what, Ms. Nuts?
Did you know the circle decided not to go to college?
Oh man, why?
It already has 360 degrees. Why do you need another one?
That's a lot of degrees. Oh my gosh. All right. Thank you for joining us. We look forward to talking to you in chapter 8. Oh, there's my vacation.
Bored. We